In this lecture, we discuss about some properties of beta and gamma function. Also, we define what is beta function. Beta function is denoted by beta of mn and defined as integration under the limit 0 to 1 x to the power m minus 1 into 1 minus x to the power n minus 1 dx, where m and n both are greater than 0 or positive numbers. Beta of mn is equal to beta of nm. So it satisfies the commutative property, means m x to the power m minus 1 or 1 minus x to the power n minus 1. This m and n can be interchanged. The third property, integration under the limit 0 to 1 x to the power m 1 minus x to the power n dx is nothing but beta of m plus 1 and n plus 1. Beta of mn is equal to, very important property, 2 times of integration under the limit 0 to pi by 2 sine to the power 2m minus 1 t cos to the power 2n minus 1 t with respect to t. Beta of mn is equal to gamma m gamma n divided by gamma m plus n. This is the relation between beta and gamma function. And if we apply these two formulas, combine these two formula, we are able to get 0 to pi by 2 sine to the power p t cos to the power q t dt, which is equal to 1 upon 2 beta of p plus 1 by 2 q plus 1 by 2, which is equal to 1 upon 2 gamma p plus 1 by 2 into gamma q plus 1 by 2 whole divided by p plus q plus 2 upon 2. Beta of mn is equal to, this is another definition of beta function, integration under the limit 0 to infinity x to the power m minus 1 divided by x to the power m plus 1. Now this m can be also converted to replaced by n. We have the same expression for that. Both are the alternate definition of beta function. Gamma m, we have already discussed these three properties in the previous lecture. Gamma m plus 1 by 2, which is equal to root pi upon 2 to the power 2m minus 1 gamma 2m. Gamma p, gamma 1 minus p is equal to 1 upon, pi upon sine p pi, where p lies between 0 to 1, and gamma 1 by 2 is equal to root pi. So these are some properties of beta and gamma function and their relations. Now we apply this different properties or different formulas to evaluate some simple problems or based on the numerical problems. Let us take example number 1. Prove that gamma 1 by 4, gamma 3 by 4 equal to pi root 2. We have to prove that gamma 1 by 4 into gamma 3 by 4 equal to pi root 2. We know that gamma p into gamma 1 minus p, which is equal to pi upon sine p pi, where p lies between 0 to 1. From 1, we have left hand side, let us take from the 1 gamma 1 by 4, gamma 3 by 4. It can be written as gamma 1 by 4 into gamma 1 minus 3, 1 minus 1 by 4, because if we simplify 1 minus 1 by 4, we get 3 by 4. If we apply this formula, gamma 1 by 4, gamma 1 minus 1 by 4, gamma p into gamma 1 minus p, then its value will be, and here clearly p is equal to 1 by 4, which lies between 0 to 1. It will be pi upon sine pi by 4. And we know that sine pi by 4 is 1 upon root 2. Then root 2 will goes to numerator and will become pi root 2, which is equal to the right hand side. Therefore, gamma 1 by 4, gamma 3 by 4 is equal to pi root 2. Thank you.